We take an example, solve the system of differential equations on system of linear differential equation. We have dx by dt is equal to 1 plus 9y, and we have dy by dt is 2 minus x. So first I am going to use by elimination method. You say I multiply by d by dt, or I go say I am going to differentiate equation 1 by t. I take the second differential of this one, differentiate with respect to t. So get here d by dt of dx by dt. And here d by dt, we differentiate both the sides, is equal to 1 plus 9y. So I'll get here d2x by dt square, and the right hand side I'll get here d by dt of 1 is equal to 0, get here 9 dy by dt. What I do, I substitute the value from equation 2 in this equation the value of dy by dt. So I get here d2x by dt square is equal to 9 times 2 minus x. I simplify this one, I'll get here d2x by dt square, d2x by dt square is equal to 18 minus 9x. I take 9x on the right hand side, I get here d2x by dt square plus 9x is equal to 18. This is my differential equation. I get a second order differential equation. In x, the independent variable is t, and it's non-homogeneous. So in non-homogeneous differential equation, we have two part of the solutions. Our x will be equal to, solution will be x is equal to xc plus xp. xc is the solution which is a homogeneous part of the differential equation, and xp is the non-homogeneous particular solution. So we take here the solution of this one. So number one, we take the homogeneous part, and homogeneous part is d2x by dt square plus 9x is equal to 0. So you remember, we make the substitution here. We say our x is equal to e to power mt. So what's my d2x by dx by dt? My dx by dt is equal to m e to power mt, and I take second derivative d2x by dt square is equal to m square e to power mt. I substitute here, I get here this as m square e to power mt minus plus 9 e to power mt is equal to 0. We take e to power mt common, and inside we get here m square plus 9 equal to 0. Now we know that because we haven't taken this as a solution and this not 0, because 0 solution we are not considering. 0 solution we call trivial solution. We are looking for non-trivial solution. So we say e to power mt is not equal to 0. That means m square plus 9 is equal to 0. Now we want to find the root of m square plus 9. And we say we get the complex root. M is equal to plus minus 3i. Then we know that when we having here, so these roots is m is equal to plus a plus minus bi. Then our solutions of this one, when we having here, for example, I'm taking x is equal to c1 e to power at, and inside we have c1 cosine bt plus c2 sine bt. So this is our solution. So here the real part is 0. So our imaginary part b is equal to 3. So we can write here my x is equal to my xc, the homogeneous part of the solution, that's equal to we are having cosine c1 cosine 3t plus c2 sine 3t. This part of my solution is number 3. Now I want to find the complementary solution. Complementary solution, we have different method. One method is the unknown coefficient, determined by unknown coefficient. So we say my x is equal to constant. I say x is equal to a. So my x dash is equal to 0, x double dash is equal to 0. I substitute in my differential equation, and I will get here, substituting it, 9a is equal to 18. That's why substituting my equation here, and we get dx by dt is 0, and we have x is equal to a, so get here 9a equal to 0. That implies my a is equal to 2, and we having taken our substitution was, which we have taken this equal to e to power x equal to a. So our xp in this case, we want to find a particular solution. So my xp is equal to 2. So I can write my general solution. My general solution is my x is equal to c1 cosine 3t plus 2 c2 Here I did rewrite this one. This is my C2 C2, here also C2 sine 3t plus 2. This is my xp. So I have my x is equal to xc. We have done this one in our differential equation course, and you know this one very well. So here I get here number 4. Number 4 is my solution for x. I want to find solution for y. I can repeat whole of this one as I get this equation after the elimination. So I eliminate it and I get the equation for y. Similarly, I just differentiate with respect to the equation 2 with respect to y, and then get d2y by dt square is equal to minus dx by dt, and put the value of dx by dt. I will get the value for differential equation for y, and then I solve in this way. I get here the solution of that one. There I will get here two variables c1 and c2. There I will get the variable c3 and c4. After that I need to find the relationship between, because we can have only this is a first order. The order of differential equation is 2. So we can keep only two arbitrary constants, c1 and c2, because the order of the system is 2. The order of system is order of differential equation 1 plus the order of differential equation 2. The total order of the system will be equal to 2. So when we have system 2, we are allowed only to take two arbitrary constants. That's when we want to find the relationship. This is method 1. Method 2 is we use the substitution. For example, I know if I substitute the value of x in number 1, then I will get the value of y. So I can write here my number 1. My number 1 is dx by dt from equation 1. From equation 1, we are having here dx by dt is equal to 1, I want to check it here, 1 plus 9y, 1 plus 9y. So 1 plus 9y is equal to dx by dt. And what's my 9y? 9y is equal to dx by dt minus 1, and my y is equal to 1 upon 9 dx by dt minus 1. Y is equal to 1 over 9, then dx by dt. So my dx by dt, I just differentiate my equation. That's equal to derivative of cosine 3t is minus 3 sine 3t. Derivative of cosine 3t is minus sine 3t, and derivative of 3t is equal to 3. So get you minus 3 c1 sine 3t. Then derivative of sine 3t is cosine 3t into 3, get you a plus 3 c2 cosine 3t. Then derivative of 2 is 0 and plus 0, and then we are having here the value minus 1. So in this inside the bracket we get here minus 1. So this is after differentiation. We simplify this one. We get here the equation y is equal to, we multiply by 1 upon 9, get minus 1 c1 over 3 sine 3t, and plus c2 over 3 cosine 3t minus 1. This is number 5. So my solution of differential equation, solution of the system of differential equation. So I always write the solution at the end and specifying with the variable. First I write variable x. My variable x is equal to c1 cosine 3t plus c2 sine 3t, and we have plus we are having here plus 2. That's equation number 4. And number 5 is y is equal to minus c1 over 3 sine 3t plus c2 over 3 cosine 3t minus 1. So this is my solution of the system of my equation. We are having here y is equal to minus c1 by 3 sine 3t plus c2 by 3 cosine 3t 1 upon 9. Now we can write the system of solution of the system of differential equation. We have equation number 2, 4 and equation number 5. Original 4 is x equal to c1 cosine 3t plus c2 sine 3t plus 2, and our y is equal to c1 upon 3 sine 3t plus c2 upon 3 cosine 3t minus 1 upon 9. This is my equation 5. So this gives me the solution of the system of differential equation. This was in non-homogeneous form. So we have to find the homogeneous part of the solution and also the particular